Today we're really going to focus on kind of a little bit about PhET, how you can use PhET in remote learning. We're going to dive into an example of an activity that you can use today, but also try to give you a broad swath for those not familiar with PhET and do some sharing. So we are going to make active use of the chat during this talk. So we hope that you can really get familiar with it, and if you are a user of PhET, really share what you know with other teachers. This is an opportunity. We are going to capture that chat and we'll include it in the materials. We are going to share all of our slides right now. This is the link that I have set up. There's nothing there, so don't go there quite yet. The slides will be shared at the end of the discussion. Ariel is here joining me today. And he is our Director of Development. He is going to be monitoring that chat and chiming in as we go through. I do want to point out that all of our resources are open source, so Creative Commons attribution, free to use and integrate into your classrooms however you want. So I couldn't agree more with Paul and with Neil that science is really this active process that begins with curiosity, our curiosity about how the world works, about phenomena that we see in everyday life, about really deepening our knowledge in all different directions. And so that's really just such an important part for us to teach our students in our classrooms. So if you could just take a moment to share in the chat, what are some of the science practices that you want your students to experience and learn, even during this remote time? Ariel is going to be monitoring that, sharing out some of the ideas. You know, for me personally, just to give you a little bit of a background, I did start out as a scientist. I got my degrees in physics, and then I went on to get a PhD in atmospheric science. So we were building a new tool to measure nitrogen dioxide in the atmosphere in a way that never been done before. And that was a lot of active work in the lab, debugging, coming up with new ideas, tying to theory, creating models, understanding the atmosphere, collecting lots of data, going out into the field. So it was super active and not about book learning so much. So Ariel, do you want to chime in and share some of the practices that you see some of the teachers sharing on the chat?
Yeah, we're getting data, evidence, modeling, students asking questions, being curious, experimentation, patterns, and analyzing are some big themes coming up.
Great, thanks. So yeah, there's just all sorts of practices. You know, you can go into like, what assumptions are you making? How are you interpreting data? How do you collect evidence? How do you design experiments? So many things, and it's so important for us to make those connections for students. So the real challenge for us right now, as Paul was pointing out, is, you know, how do you make learning science more like doing science, getting them involved in the process of science inquiry, science practices, and problem solving? We all know that you have content knowledge that you have to convey to the students, that they have to understand when they're done with your classes. There's science standards, after all, and they aren't all practices, but how can you have teachers engage, how can your students engage more in science inquiry in a way that they can also be advancing their understanding at the same time, just like scientists do? And here at PhET Interactive Simulations, we've been leveraging the power of interactive simulations to provide environments to do that for students, a place where they can engage in discovery, where it connects to their everyday life, where things can be intuitive and more understandable, where we use many different representations. And so these tools can be used to develop both their practices and understanding through a lot of agencies. So just briefly, if you're not familiar with PhET, we currently have 158 simulations, 83 in HTML5. You'll find teacher resources, 2,000 sim-based lessons. They cover physics, chemistry, math, earth science, biology. They are used K-12 through college, and they're all open educational resources, and they're translated into 90 languages, so they can be useful for English learners as well. So you can't really understand PhET or even think about how to use it without seeing some simulations. So we're going to do a brief tour of some simulations. You'll see that they're open and flexible, so you can adapt them to your class and your specific goals. For those of you that have used PhET before, as I'm sure there are some people on the line, I do want you to be using that chat. So Ariel will be monitoring, chat your favorite sim, a teaching tip, a question. Ariel will share some of those out. And at the same time, you'll be sharing them with each other. So let's go ahead and take a look at some of these simulations. So build an atom, basic chemistry simulation, but it's a super basic idea, but it's often the kind of idea that it's hard for students to learn through inquiry, because in the real world, you can't change an atom. But here within the simulation, you can, and students can be doing this directly, and they can be using these measures of net charge and mass number to build up their understanding about, some of the important concepts about atoms. You see every time I add a proton, the atom element names changes, but it doesn't change when I add neutrons or electrons. One of the things you'll see, I could get to it, is that the simulations have these different screens at the bottom, but I can't reach mine because of the share. So here it scaffolds up to more high school topics where you're learning about how chemists represent these ideas in chemical symbols. Sorry. Here's another simulation, projectile motion. In this simulation, you can teach qualitative or quantitatively. So, so you can project out different projectiles. You can measure, take data about how far they go and how much time. Have students plot up things like the distance versus time, determine the horizontal and vertical velocities. You can do things like turn on air resistance and see how a pumpkin's air resistance impacts a pumpkin more than it impacts, for instance, a car. And you can have students reason about why that might be and come up with ideas, share ideas. As a tribute to our keynote speaker, I wanted to share this sim. This is gravity and orbits. If you're teaching about earth science, for instance, you can turn on forces, show the path, show the velocity. You can have students do experiments. So they can go back to the beginning. They can do things like, what's going to happen if I increase or decrease the velocity of the earth? What's going to happen if I increase or decrease the velocity or the mass of my star or the mass of my earth, and see how that impacts the orbit. And they can look at these different types of orbiting structures. There's this force and motion basics. This one is useful basically from elementary all the way up through high school. If you're in elementary, you might be just looking at force balance and what impacts how fast one of these sides wins, or if I can if I can change the direction of the wind. It scaffolds up to sorry, having some Zoom issues getting to this slide. Okay. You can look at this screen, which lets you investigate more about force versus acceleration, changing directions, effects of mass on those aspects. So along with these simulations, oh, Ariel, were there some ideas that came out of the chat about teaching tips or favorite sims that you wanted to share?
Yeah, lots of favorite sims, certainly ones we know about. Force and motion basics, like you showed. People love the circuit sim. Chemistry teachers loving balancing chemical equations. And there were some comments about really loving that we have basics versions of our sims these days as well.
Thanks. Yeah, it's really, we try to make these simulations super flexible. So many of them actually can flex all the way from elementary to high school, or even up to college, and we'll see an example of that later. At our website, what you'll find are some teaching resources. So we've put together some specific tips for remote learning that you can find up there at the top link. We also, with each simulation under the For Teachers link, you'll find tips for teachers, a video primer that's oriented towards giving you a really quick overview, and then a whole bunch of lessons. So all these lessons are also open, and they can create a good starting point for you to adapt and create your own lesson that matches up with your particular learning goals and your students. I wanted to point out 3 things that we've added. So we've added Google Docs sharing to those lessons plans. We've added a remote lab tag, and we also now have browser compatible Java simulation. So if I go back in here and I go under For Teachers, I can click type, and you'll see remote learning. We've put that at the top so that now we know everybody's doing remote learning. So if you're making remote lessons around PhET Sims, we do encourage you to share them up here, or start with finding those, or adapting some of the other lessons for remote learning. So I do want to get to the activity, so we're going to move along and think about when we're engaging students in these STEM practices. It's really important to get them over on this side where they have student control and they can do some hands-on labs and activities. So today we're going to focus on do a little activity around this simulation. It's the Circuit Construction Kit. It's one of our most popular simulations. Has 9 million runs this year. And we're going to look at what an elementary activity could look like and what a high school activity looks like, and how you can build them to support students working remotely. Our top tip really, just as Paul was saying, is not to start with explanation. Don't tell them how to use the simulation. Don't give them like a little diagram. Students are kind of natural explorers, and they will just touch and play with everything. And the only reassurance maybe they need is like they can't break it. So, starting with Open Explore is a great way to make this tool theirs and start tapping into their ability to engage their curiosity, do some observations. So now it's your turn. I really do want you, if you can, if you're at a computer, to go and play with this simulation. So we're gonna hop over to Google. We are going to type in PhET circuit. Be the top simulation that comes up, top link in your Google search. And then you can start up that simulation, and I want you to be doing this. I want you to take just a minute to play with it. And then as you're playing with it, if you have a moment, share in the chat, like a discovery you found, a favorite feature, a reflection about this simulation as a learning tool. For those of you that aren't on chat, I'm just gonna pretend to be a student here. So I see a whole kit over here. I'm gonna pull out a battery. Okay, I'm gonna try to light this bulb, sort of a natural challenge that's built into the sim. Okay, I've hooked it up, but it's not lit. Okay, so how do I get this sucker lit? So maybe I have to do something like this. So if you can't see it, I have some flames right now. My battery's on fire. The electrons are going crazy as they go around the circuit. And really that is giving them direct feedback about sort of what is a short circuit. They see the electrons go around. And then they can keep going and working. There's a lot of other features in this simulation. You can pull out tools. You can measure voltages. You can measure currents. We have both this special current ammeter, but then in another screen we have one that's an inline current meter. Ariel, have there been some, anything in the chat? People still playing.
Sorry, major Zoom issues. Chat's freezing on me, so I'll tell you in a minute.
I can try to look at the chat maybe. All right. Well, I'm going to move on, and then maybe Ariel can chime in. But I hope you did get a chance to play with the simulation on your own. It is really a powerful simulation that can bridge all the way up to high school. So the next tip on this activity, or these two compared activities, elementary and high school, same sim. In elementary class, both types of activities, we encourage you to use what are called challenge prompts, okay? So the inclination might be that even during this time, I really need to tell students exactly what to do. But they're going to be more motivated, more interested. They're going to be engaging in more practices if you use challenge prompts as opposed to giving them really specific instructions. So with the elementary class, you might say, make the light bulb shine brighter. Or you might say, oh, a flashlight also has a switch. So let's turn the circuit into a flashlight. Can you figure that out? Have them take snapshots. In a high school class, you might have them explore all the different ways that they can make the light bulb brighter. There are many ways. In elementary, they'll probably add more batteries. I've seen students add 10 batteries in a row.
I'm going to interrupt you, Kathy. There's
Yep.
lots and lots and lots of questions on the chat about Chromebooks. So let's be clear. Every single one of our HTML5 sims works perfectly on any device. Kathy's also going to mention how many of our older Java sims, we now have a stopgap solution so they can run on a Chromebook. So we can hop to that if you'd like right now. I mean, that is one of the main questions coming up on the chat is everyone's talking about, well, the Java sims versus using on Chromebooks. So it may be useful to just pause for a moment, address that, because that's like tons of the chat.
Thanks, Ariel. Yes, so if you see an HTML5 badge, that means it will run on a Chromebook for sure. That's our redesigned next generation simulations. Some of the ones I've been demoing. You can even embed them in different, like in a web page, or create a link from a Google Doc, and it will totally work fine. We have 3 different kinds of sims. I'll just hop down a little bit to my slide here. So we have 3 different kinds of sims. We have HTML5 sims, the ones that work on anything, even phones. Java sims, those only work on full computers. They will not work on Chromebooks or iPads. Flash sims, those will work on Chromebooks, at least right now, and on computers, but won't work on iPads. But we have developed this, we've worked with this company called Leaning Technology to just now publish some simulations called Java and ChirpJ. And this opens up a whole bunch of different simulations for use in a Chromebook. So it is a technology that takes a Java simulation and basically lets you run it right in the browser. So I'll just launch one. You can see that it takes a little while to launch, but so it does take a performance hit. But it will launch in the browser in a Chromebook. It might be a little slow. You should test it on the devices that you think your students will have, just to make sure it's going to work okay. Like this is currently taking a while to start up. But once it does, it works fine. So you can see the Java, it looks just like the Java sim. It's not redesigned. Don't expect anything more than the Java simulation running in a Chromebook. But it does open up a lot more simulations now. And we are working on integrating this solution into our website. So right now it's a really you'll find them as a really brief solution. So if we go to all sims and we hit one of the ones that is still in Java, you'll see this little tag, and this brings you, these chirp JSONs bring you to the browser compatible version. So that's one way to find what's browser compatible right now. By the end of the summer, we'll have it all integrated and you'll be able to access them right here.
No, someone asked if it's only available till July. No, ChirpJ will be available for as long as we have Java Sims. So it is a solution that we're using so that is a stopgap solution until we are able to convert the Sims to HTML5. HTML5 is the best solution, but these allow, someone in the chat even said, you know, not perfect on iPads, but at least I can use them now. So we're very excited about that. There was also a question about, can our HTML5 Sims be run offline? Absolutely. Every single one of our HTML5 Sims can be downloaded and run offline seamlessly.
Yeah, just hit this download button here. The note about July in the slides was that by then we'll have it fully integrated into the website and you won't need to go to the Google Doc. The Google Doc's kind of early access, our way of creating early access. In July, we should have access directly through our website. Okay, any other critical questions there on the technology side, Ariel?
No, I think that helps out.
All right, we are so excited to have that solution for you because we know that running Java.
There is one question that came up on stopgap for Flash, which is not yet, but we're looking into it.
Yeah, the same company that has the stopgap for Java is developing one for Flash, but it's not ready yet.
Can you also, if you have 1 second, just show where the early prototypes, there was someone asking about density and some other things, and I think we're about to get talked to by Dave.
Okay, so yeah, we have, if you go to our homepage, we also have the HTML5 prototypes here. So we did, we will continue doing this as simulations get close enough to being released. You know, we will release the HTML5 versions even though we haven't fully finished all of our quality assurance testing, if we feel like they will be beneficial to you and we don't know of any major bugs. If you use a prototype and you find a bug, please email us. Also, if you are using a simulation, designing an activity, and are like, hey, this would really help my activity to be able to reach more learning goals, drop us a note. We get teacher recommendations all the time. And if it's easy for us to add it in, you know, we review them and it's really helpful. It helps us with our design process. This simulation has some fun things, including we created this new challenge screen where you can have different sets of blocks that students can have to measure the density of them.
Cool.
Using the volume and the mass scale over there.
So Kathy and Ariel, sorry, I got to jump in. We just got a couple minutes left, and we want to give these poor teachers a break. we've skipped all our breaks.
Sure.
I feel sorry for everybody, and thank you everybody for hanging on. By the way, you're ton of interaction on chat, and I'm glad you're capturing that. There's probably a bunch of questions you can go back and answer. Is there a place people can go? There's a lot of technical questions. You know, does it run on this? Does it interface with that? Where should people go? Is there like one place that can go and get that kind of information?
Absolutely. If they go to scroll to the bottom of our website, which Kathy can show, there's something we have called our Help Center. And our Help Center answers all these questions.
Okay, so
Yep.
get it in real time.
Scroll to the footer,
Right.
click on the Help Center. That's going to tell you how you can run the Sims.
Getting started, running Sims, has different devices, Mac OS, Windows, iOS.
That is beautiful. I think that's what people were looking for. Thank you very much. That's going to be really, really helpful. Hey, I have a question for you, a couple of quick questions before we wrap up. So how do you, or do you think about how to recommend teachers integrate this with physical lessons. So if somebody's doing a roller coaster and then they could simulate some of the physics, how would they work together? Do you have best practices for that, or do you think about that? Is that part of your
Oh yeah, I mean, we think about it, and we are all scientists, and so we are big believers in hands-on work. So, for instance, the circuit construction kit where the students were working with that, it's great when you have an opportunity to pair that with real circuits, so they can kind of build their model using the simulation, get this idea of the current flowing through, this visual in their mind of electrons flowing, and the the role of voltage and resistance, and then they can use that to apply to real circuits. We've seen that students can make that transition really well, and then be much more productive and thoughtful in how they're working with real circuits and debugging and things like that. So it can go both ways. You can start with the phenomena and then use the simulation to digest the model and add in the visuals, or it can go back the other way.
Yeah, it's great you say that. In our last conference, we had Brown Dog Gadgets. I don't know if you've ever seen them, but they make these circuit kits that you can build all kinds of different things. They have conductive tape. They have, like different circuit components. And they're fun kits and everything. And if you added simulation on top of that, you'd have something really, really cool and really rich.
Yeah, I think they really complement each other very well. Because the physical, having the thing in your hands really, really adds a lot. So.
And I think we talk a lot about making the invisible visible. So you could have a student make their own pendulum, but they can't necessarily see velocity vectors or acceleration vectors, where you can visualize those in the simulation.
It's funny, in a prior life, I worked in the semiconductor industry, and we did a lot of R&D in optics and lithography. And we always had this saying, if it works in practice, it works in theory. Because sometimes you discover stuff and, oh, okay, well, if it works, there's a theory to explain it.
You got to find the theory.
You got to find the theory. Let's see, all the tools you have. Is there any other roadmap stuff you want to let people know about? I think you covered a lot of ground, but is there anything people should be looking for?
Definitely take a look at the remote learning tips that are linked from our website. We're working on bringing more simulations to HTML5. The Chirp J1s really help a lot. And we are here to answer questions. So I guess that my last slide was just going to encourage teachers. I know there's a lot of teachers out there building lessons around PhET simulations. If you don't find what you need in terms of lessons at our shared lesson bank and you make one, please share it back so other teachers can use them. Some of those lessons are downloaded, thousands and thousands and thousands of times, so you'll really save a lot of other teachers.
This is fantastic. And people can reach you. I think everybody's got the website. We're going to send out information. So anybody in chat, we're going to send out links and materials, and we'll collect that from all the presenters. It's going to go, if you're on Zoom, you've registered, and we'll be getting that out a couple of days after the conference. So Kathy and Ariel, that is so fantastic. I can see you have a ton of fans. I even saw on Twitter, there's like a ton of people saying how PhET is so amazing.
I guess there's one thing I want to add. Based on what Paul was saying, PhET sims are super flexible tools. So any chance you have in your remote teaching to be able to interact directly with the students, you can engage in that inquiry directly by sharing screens with the students, having them make predictions, having them share their solutions. So if you can do sort of that personal interaction using Zoom and a PhET sim, it's great.
Great. So thank you, Kathy and Ariel from PhET. And thank you so much for making this a great session.
Thank you, Dave. Thanks, Cliff, for inviting us.
You bet.
Bye, everybody.